Dear viewers, welcome to Data Structures and Algorithm. I hope this video will be of immense use for the beginners. Data structures. The quantities, characters, or symbols on which operations are performed by a computer, which may be stored and transmitted in the form of electrical signals and recorded on magnetic, optical, or mechanical recording media, are all data. For example, C is equal to A plus B. The value of A and B is been added and has been assigned to C. This is an expression which derives an operatable and operated data. So in the above statement, an operation is performed on both quantities, and these data are operated, stored, and transmitted, thereby conforms to the conditions of what is being called as data. So when does this data become information? Data is a collection of characters such as anything, a combination of characters. But just combination of characters are not data, because if it does not give us any meaning, or if anybody will not be able to derive any meaning from the group of characters, no way it is called as a data. When it derives meaning, it becomes data, and that can be transformed to information. So when meaning is extracted from data, data becomes information. So in simple words, if data is in an order or in a systematic way, it gets a structure. Such processed data becomes information. So thereby, to get information, data need to have a structure, and for that, one need to know data structures. So what are primitive data structures? Primitive data structures are the most basic data structure available in all programming languages, such as int, float, character, boolean, double, etc. Non-primitive data structures are complex data structures that are built using primitive data structures such as arrays, linked list, stacks, queues, trees, graphs, and hash tables. Arrays, it is a collection of homogeneous elements stored in contiguous memory locations. What are linked lists? It is a collection of homogeneous elements that are linked using pointers, and it overcomes the problem of array which takes contiguous memory. Stack is a collection of elements that follow first in, first out mechanism. Queue is a collection of elements that follow last in, first out mechanism. Tree, in simple terms, a hierarchical data structure consisting of nodes that are connected by edges. Graphs are nonlinear data structures consisting of nodes and edges. So let us see about all these in detail in the future videos. Hash table is a data structure that stores in an associated manner, that stores data in an associated manner using a hash function. And these hash functions are computable functions that results in hash values. Set is a collection of unique elements, and map, it is an abstract data type that contains key value pairs. So choice of these data structures for a particular task depends on what type of data we process, and what is the amount of data that we process, and what operations do we need to perform on these data, and the efficiency requirements of these programs. All these determines the type of data structure what we want to use on these. So the idea of data structure is to reduce the space and complexity of tasks. So why is data structure required? Data structure is required for a little few reasons. Imagine if there are 1 million data available, and if an item needed to be searched, the entire quantum of volume of data need to be searched. Every time a search occurs, the whole bunch is searched, slowing down the search operation. So though the speed of the processor is high, if the data grows to 1 billion and if the data keeps growing, as how these days every day we create millions of data, processor has its own speed limit. Therefore, the search operation is slow. So too many parallel requests, when there are too many hits parallelly from the clients looking for data, the operation naturally becomes slow. So to resolve the above constraints, data structures are needed. Data are organized in a structured way based on the type of data and the operations to be performed on that particular data. So what are the characteristics of data? Every data has got its own characteristics, as we discussed earlier. Every data, for example, collection of characters is data, collection of numbers is a data, numbers with decimal points are data. So data are of different types, and the structure and the way how we need to process and organize it decides what type of data structure we need to look in. Time complexity. There are more than one way to solve a problem using different algorithms. There are methods to find optimal algorithms using time complexity and space complexity. Time complexity is not the time taken by the system to execute. For instance, a program that is run in a system might take 2 seconds, whereas if it is run in a system with a better configuration, it might take just 1 second. And if tried in a very recent configuration system, would take much lesser than even 1 second. Therefore, it is the time taken by the algorithm to run as a function of input size. What is space complexity? Problem solving using computer requires memory to hold temporary values or final result while the program is in execution. The amount of memory required by an algorithm to solve a problem is called space complexity. Space complexity is the amount of space required for an algorithm to run as a function of length of input. The focus is actually on two parts, a fixed part and as well as a variable part. A fixed part, it is independent of the input size. It includes memory for instructions, variables, constants, etc. Whereas a variable part, it is not dependent on the input size. It includes memory of recursion stack, reference variables, etc. And in general, there are three cases named as worst case, average case, and best case. So which is the worst case? Defining the input, worst case is when algorithm takes long time or the maximum time. Which is the average case? It calculates the computation time of all random inputs divided by the total number of inputs. Average case is all random case time divided by the total number of inputs. Best case defines the input the algorithm takes less time or the minimal time. What is an algorithm? We all know that it is a step-by-step procedure. It provides a set of instructions for a methodical implementation of ideas in a particular order. Algorithm is independent of any programming languages. It can be implemented in any program language. It is just a collection of steps. So every algorithm need to be analyzed. Implementation of an algorithm definitely consumes CPU time, memory, drives, and network. But the focus is much on CPU time. Generally, algorithm is analyzed based on time versus the input size, represented as T of n. In simple words, complexity of an algorithm computes the amount of time and space required for the algorithm for the input given size n. So what are all the categories of algorithms? Generally, algorithms are devised for searching, sorting, inserting, and updating. Searching for the presence of an item in a data structure. Sorting, if at all the client wishes to arrange the data elements in an order. Inserting, if we need to insert elements in a data structure. Updating is to update elements in the prevailing data structure. Thank you. I believe this video will be of use to you. We'll meet you in the second video.